Okay, this is lesson 32, altitudes and medians of triangles. So let's define these words first. An altitude and a median are related, but they are not exactly the same. Altitude basically tells you the height. So altitude, just like it is in a plane, or when you're just talking about how high your elevation is, it's talking literally about your height. Okay? So to describe this, if I had a triangle, I'll just draw one real quick, and I wanted to find the altitude of it, I would take its highest point and make it a perpendicular with the base, and my altitude would be the height, what I just labeled h. Okay? Now, let's define what a median is. So I'll draw it for you as I'm defining it. So you need a triangle. Let's draw a triangle real quick. Make it kind of big so you can see what you're doing. Okay? So what we're defining is the median of a triangle. Alright, so the median of a triangle is a segment whose endpoints are a vertex of a triangle and the midpoint of an opposite side. So here we go. I'm going to label this triangle A, B, C. A is going to be at the top, B is on the bottom left, and C is on the bottom right. So to define a median, it is the connection of an opposite vertex to the midpoint of a side. So if this is my midpoint, I'm connecting the opposite vertex to it, and by definition of midpoint, the segments that are created by the midpoint are congruent to each other. If I wanted to create the midpoint of AC, again, I would just have to cut it in half. 1, 2, 1, 2. Okay, and I'd connect B to that midpoint. These are our medians. These lines are our medians. These lines are the medians. Okay, and last one, if I was going to make C's median, it would go to the midpoint of AB. 1, 2, 3, 1, 2, 3. Those tick marks signify that I've made a median because it is in the middle, and they will meet at a point right here. Okay, this is called the centroid. So I'm going to draw a line, centroid of a triangle. So the centroid of the triangle is where all of the medians intersect. So let's annotate that in our definition. The centroid is where, whoops, that's a W, not an N. Where the medians intersect. Okay, so the centroid is where the medians intersect. Alright, now there's some nifty little rules that we can find out about these things. I have to zoom out for that. Any questions over those definitions before I start going over some rules? Alright, this is theorem 32.1. It's centroid theorem. Okay, that's how we'll identify it, centroid theorem. What it says, basically, I'm going to use this triangle up here as a picture for what it's saying, is that the distance, the long side, is 2/3 of the entire length. Okay, so the distance from B to, let's call the centroid C. No, we can't call it C. Let's call it P. Okay, so label the middle of your triangle where all the medians meet, P. So basically it's saying that BP is 2/3 of the whole length. We're going to have to label that side something. Let's call this X, call the bottom one Y, and the left one Z. So BP is 2/3 of BX, and that's the measures of them. Okay, so since it's 2/3, we also would know that PX, the small side, is 1/3 of that thing. So I wrote my formulas backwards. So let's erase that so we can get these straight. So when I state my definitions, it's not improper. So we have 2/3 VP is 2/3 of the entire segment, BX. Okay? And then PX, the small piece from here to here, is 1/3 of the entire segment, BX. Okay, so I feel like I'm gonna, because the way I messed that up is gonna confuse you. So here we go. I'm gonna redraw my segment across. Okay, I'm just moving this down here. So this is B, and this is X, and then somewhere in this area is P. Okay, so I just recreated that segment. This is the centroid right here. P is the centroid. So the distance from here to here, from B to P, is 2/3 that of the entire segment. Okay, and the distance from P to X is only 1/3 of the entire segment. So it's just breaking it down. And we can answer some questions based off of that knowledge. And it works on every single one of them. So if I look back here, I'm going to start looking at each of these. Got to zoom in pretty far to get that to work. Okay, so if I'm talking CZ as the whole segment, then CP is 2/3 of CZ. Okay, and looking at PZ, which is the smaller section, it's 1/3 of CZ, the whole length. Okay, so basically, as a general rule, you can just say that the small piece is 1/3, the big piece is 2/3, and we can break down from there. Okay, so let's go to example 1 and see what we can establish. It gives us a triangle, and you're going to need to look in your book. Okay, so this triangle is the one that I'm zooming in on. Let's let it focus in a little bit. That's a little better. Okay, so it says in this triangle LMN, LA, so I'm looking at the total length LA, okay, LA is equal to 12. And then it says OC, so the distance from O to C is 3.1. It says find LO. So I'm looking at the distance from L to O. Okay, based on the knowledge of O to C. Okay, so we're going to use our centroid theorem. We're going to set up a rationale for each of these. So let's start it. All zoomed out here. Using the knowledge that they just gave us, we know that the distance of L to A is 12. So we write down the important information. Okay? And we know that the small section is going to be 1/3 of it, and we know that the big section is going to be 2/3 of it. So the big section is called LO. So if the full segment is 12, we're looking for the big segment, which is LO. We're looking for 2/3 of it, and that will give us our answer. We can use our calculator if we wanted to, or we can just multiply them. It doesn't matter to me, whichever you want to do. You're going to use your calculator. Make sure you try to put it in parentheses here. So 2/3 of 12 is 8. Okay, you can type in your calculator if you want. So LO measures 8, whatever their lengths are being measured in, units. I guess we'll just go with units since there's no measurement labeled there. 8 units. LO is 8 units. Again, that was because it was the longer length. So if I pull this out of the drawing, it's going to look like this. L, and then it ends at A. So the total length is 12. And then the centroid was labeled here at O. So the distance from here to there is 2/3 of the total distance, 2/3 of 12. And the smaller distance will be 1/3 of that. Okay, and then it'll be that way every single time. Okay, example 2. This little bit of information that they gave you on example 1 that said OC is 3.1, that was just extra information that you didn't need. They gave that to us just to kind of get you off track. You have to know what to ignore and what you actually need. Okay? The next question in that one wants us to find NC. I'm still on example 1. I'm sorry, I didn't finish the question. So NC for this part goes from one vertex of the triangle all the way to the other side. So it wants us to find the total distance from N to C. We don't know what that is yet, so I'm going to put a question mark. Okay, the centroid is located here again, still at O. So OC, this part right here, is 1/3 of that piece. So it's 1/3 of that piece. Okay. Now they told us that OC was 3.1. So for the second part of the question, it's important. So since OC is 3.1, I'm going to go ahead and write that in and get rid of this 1/3 part. We still need to know that it's 1/3 of the whole thing. And I can write my formula. Okay, 1/3 of the entire thing, which is going to be NC, is 3.1. And then I have to solve. Since it's 1/3 of, or 1/3 multiplied by, I can get rid of the multiplied by dividing. I divide it by 1/3, divide it by 1/3, and that would go away. And NC is then, because I can't divide by a fraction, I have to multiply by its reciprocal. It turns into 3.1 times the reciprocal of 1/3, which is just 3. And we get 9.3. Again, you can use your calculator to do this. We have 3.1 divided by 1/3. Gives us still the same answer. Okay? 9.3, I guess units, because they don't give us a measurement. So NC is 9.3 units. Okay? Questions? Gotta have some questions, guys. Alright. Example 2. This one's a lot more complicated. It gives us a coordinate plane. Okay? On this coordinate plane, they label some points, which are actually kind of nice. You're going to need to look in your book for it. So it says find the centroid of triangle DEF with the vertices, and then they label the points for the vertices. So you would have to make this, and it looks like they're all in quadrant 2, so I'm going to go ahead and make that a big piece. Okay? So when I drew this out, I made quadrant 2 the biggest piece because all of these points are in quadrant 2. So it says point D is at -3, 1, 2, 3, and up +5. 1, 2, 3, 4, 5. You can use that stamper I have if you'd like. Next point is at, that was D. Next point is at -2, 1, and that's E. Oops. This is E. Last point is at -7, 3, so I need to go out quite a few more. 1, 2, 3, 4, 5, 6, 7. And we're going to go up 3, 1, 2, 3. So here we go. And that was point F. So here's my triangle. It tells me to find the centroid of it. So in order to find the centroid of it, I need to find the midpoints of F and D, the midpoints of D and E, and then the midpoint of E and F. What is the definition of midpoint? It's the average of the 2 points, right? So if I take the 2 points, knowing that D is -3, 5, E is -2, 1, and F is -7, 3, I can find each of the midpoints by just doing the math. So here we go, -3, 5, and I'm going to find the midpoint of D and E, -2, 1. So if I'm going to find the midpoint of these, I'm going to add them together. 5 and 1 make 6. -3 and -2 make -5. I'm going to divide them by 2. Divide them by 2. So there's the midpoint of D and E. So if I want to find the midpoint, it's -2.5, and 6/2 is actually 3. So it's -2.5, so 1, 2.5, and up 3. So I go 1, 2, 3, and my midpoint is right here. Okay? So now I know that this segment is the same as this segment, and I can start my centroid by connecting the opposite vertex to it. Okay, so you draw your line. Next I'm going to find the midpoint of E and F. So E is -2, 1, and F is -7, 3. I'm just finding the midpoint. So I'm going to find the average, just like I said. 1 and 3 make 4, and negative 2 and negative 7 make negative 9. I divide that by 2. I divide that by 2. So 4 halves is actually just 2. So to find this point, it's negative 4 halves, comma 2. So negative 1, 2, 3, 4, comma 2 is up 2. So here is my midpoint. I'm going to label each of those segments equal because they are midpoint. I'm going to connect it to its opposite vertex. Now here's the good part about this. In order to find the centroid, you don't need to find all 3 sides. You only actually need 2, because they're all going to intersect at the same point. So looking back at this one, because they all intersect at the same point, where 2 of them intersect is going to be the same as where the third one intersects. And it doesn't matter which 2 sides you find first. Okay? So there's your centroid right there. It's where those 2 intersect. Now here's the tough part. They want an exact answer. We do have a calculator that will help us out a little bit, but if you don't pay attention, you're definitely not going to be able to find this. So on one of the definitions that I gave you in your study guide, it will ask you what is point slope. So here it is. This is point slope. So after I've drawn this, I need to find the exact point that it intersects. So I need to find the equation of this line. Okay, the equation of this line is created by the intersection of D and the intersection of the midpoint between E and F. So the first point is going to be just where D is. It's negative 3, comma 5. The second point that I'm going to use is going to be the intersection of F and E. We just found the intersection of F and E. It was at negative 4.5, comma 2. I write it as 4.5 because it's easier for you guys. I feel like y'all guys are better with decimals than you are with fractions. I start plugging them in. I have to first find the slope. So here, let me help y'all guys even further. I'll show you a way to find slope. Grab your graphing calculator if you don't have one. Alright, let me see if I can get rid of this shadow real quick. Whoa, too much. Alright, click on Stat. Turn it on first. Click on Stat. Go to Edit. In your lists, you are going to list the x's. The x's are negative 3.5 and negative 4.5. Oh, I'm sorry, it's not 3.5. You're right. Yeah. So I've entered in those 2 points as my x's. In my second list, I'm going to put my y's. My y's are 5 and 2. So 5, 2. Hit Stat again. Go over to Calc. We're going to do linear regression. Okay, see it's an ax plus b. The a will be our slope. So if we press that, it'll probably ask you, what do you want for your x? What do you want for your y? List 1 is your x's. List 2 is your y's. Okay? And it spits out what your slope is. My slope here is 2. My intercept is 11. Okay? So that's a quick way to use this. If not, you're going to have to do it this long drawn out way that I'm about to show you. Okay? So in order to find slope, I take the difference in y's. So I'm going to take 5 minus 2 over the difference in x's. So I have negative 3 minus a negative 4.5. That turns to a plus. I get 3 on top, and I get 1/2 on bottom. I take 3 divided by 1/2. 3 divided by 1.5. And I get 2. So my slope was indeed 2, just like the calculator told me it was. Yay! So I'd plug that in, I'd plug 2 in, and I'd start filling in my formula. And it doesn't matter what point you use, I'm going to use the one that is whole numbers, or sorry, integers. So it's x minus a negative 3. Here it's y minus a 5. and I start solving. I'm going to fix this, make it a plus. I have y minus 5 equals, I'm going to distribute this 2, I get 2x plus 6. Finish solving this, I add 5. I add 5. Y must be 2x plus 11. And what did our calculator give us? 2x plus 11. Okay, so there's our first equation. Now we're going to do just calculator work on the next one, but you have to know what to plug in. I need to know the equation of this line right here. So it's the line that connects the points negative 7, 3 to the point that is the midpoint of D and E. The midpoint of D and E was negative 2.5, 3. I'm pulling that from the work that I did up here. Okay? Since I did the work, I'm going to use it. Now I just take my calculator, I plug in those points, hit stat, go to edit, clear out the points that are already there. I'm going to put in my new points. My new x's are negative 7, and negative 2.5. Come on. And then I'm going to put in my y's, which are 3 and 3. That was easy. Because I have a 3 and a 3, I already kind of know something about what my line's going to look like. What did you say? She noticed, or she already hit it, I don't know which one she did. Do ln reg of it again. You're going to get, your slope is 0. And your y-intercept is 3. So if I recall the formula, this is your slope-intercept formula, y equals mx plus b. And that's the form that they put them in, y equals mx plus b. Okay, I take my slope, y equals 0x, plus my b, which was 3, and I finish solving this. 0 times x is what? 0. What's 0 plus 3? 3. So y equals 3. So here are my two equations. I'm going to need these. Take it in your calculator. Press y equals. You're going to type in 2x plus 11. Okay, 2x plus 11. Oh, that's a little better light. And I'm going to take in my other point, or my other line, sorry. Y equals 3. Make sure that on your graph, these aren't shaded, because otherwise you're going to have some weird stuff show up when we press graph. Press graph. You should see a point of intersection is right there. Okay, we should already see that point of intersection right there on our original graph, but looking at our calculator, we should see it again. I need to find out exactly where that crosses, so I'll hit second calc. I'm looking for intersect. It tells me first curve. Really, it's just asking what is the first line. For me, it was the 2x plus 11, so I'm going to press enter. Now it jumps. Second curve, it's asking for the second line, so I'll let it be y equals 3, just like it says in my calculator. Yes, it was. Now it says guess. Where do you think it's going to cross at? So I'm going to jump over here to where I think it crosses at. Well, I think it crosses right there. And then it gives me the exact answer. Negative 4, 3. So I'm going to draw that. It's negative 4, 3. So all I did was connect my line. Negative 4, 3. It's a lot of work. A lot of steps. Specific questions?
What would this be used for?
What would this be used for? As in what? What do you mean? Looking for the intersection of two things? You want to think it in the concept of marketing, or do you want it in something else? Marketing is pretty much all things mathematics. So if you're considering two different, they always use cell phone companies, or you could consider cable companies, or electrical companies. They charge you by the kilowatt hour. So you want to know where two companies meet the same cost. Maybe as in services kind of deal. So this part of this equation deals specifically with, say, marketing for this example. Finding the centroid of a triangle, that would be more architectural.
Okay.
How do you zoom out on the window?
Press zoom, and there's an out. Okay. Turning it off and turning it on does nothing except for turning the screen off. No, it didn't go away. No. Alright, moving on. Example 3. Now this gives you another new definition, so you need to realize what this is. So where we connect the medians, okay, so make this note. Medians make centroid. Whoops, that's a C. Okay, you need at least 2 of them, so you might make a little note, median, put like 2 of those. Make centroids. Okay, so medians make centroids. Altitudes make orthocenter. So this is the new word that we need to define. So basically, an altitude connects the highest point to the base with a right angle, right? That's what we decided. Now if I turn this and I make a new base, I make a new base, all I've done is made this my base, and I connect the altitude from this base with again, a 90. Where they intersect is called the orthocenter. So the point of intersection is called the orthocenter. Okay, now of course I could have turned this one more time and looked from this base and drew the altitude from it, making it a 90 degree, but of course it's going to intersect at the exact same spot. Indeed it does if you do it correctly. Okay, so I find it easier to rotate my paper. If you are creative enough, you don't have to rotate your paper, but I'm not, so I do. Okay, so orthocenters are just created by doing that. Now here's where they get complicated, because sometimes the orthocenter is one of the vertexes. So where that makes life way difficult. Or sometimes the orthocenter is not, I repeat, is not inside of the triangle. Now let me basically tell you what an orthocenter is used for. An orthocenter, the orthocenter creates a place for you to stick the sharp end of your compass, and then you're supposed to be able to draw a circle. Let's see if I did this right. Hold on, not done yet. Oh, I didn't do it right. Dang it. Oh, because I was doing the wrong thing. Here we go. Let me erase that. The orthocenter is supposed to, see if I can remember how to do that. No, it's not. It's supposed to, yeah, you're supposed to be able to connect it to all the outside. But I'm not very good at drawing this. I try. Okay, so that's basically what it is. But in order to create them, you can do that by just connecting the altitudes of all of them. So here's an example of one that you would, because they're going to ask you to draw the orthocenter of one of these triangles. So here, draw this triangle. It is going to be a flat base that meets basically in the middle. Okay? Yeah. Oh, sorry. Way earlier here. So draw one of those for me. Okay, the altitude of this one is fairly easy. Yeah.
On our we got figures.
Okay, I'm connecting the altitude, or making the altitude of this one. Now when I turn this, because I'm not very creative, I go, oh man, how am I going to create the altitude on this one? So look, because this is the highest point, right? And if I dropped an altitude directly from this one, it's not going to be on my base. So I'd actually have to run a fake extension out this way. So here's my altitude on this guy. And I'm going to extend this down because we're going to need that later. Now if I run the base from the other side, again I have that same exact issue. When I drop this one and make my 90, it's going to meet right here. And again, they never intersected. So I'm extending each of my altitudes because I need to figure out where they cross. And they cross right here, which is not in my original triangle. Okay? So I want to create an altitude off of each of my bases when I turn it, but sometimes the orthocenter will not be inside of your triangles, which is kind of annoying. Okay, got to be able to draw them, be able to locate them. So in your book they give examples 3 different ways you're going to see it. Okay, so use your book to your advantage there. Example 4. Application of balancing objects. Again, this is architectural. So a centroid of a triangle is a point where the triangle can be balanced on a point. Suppose that a student wants to perform a balancing act of triangles as a part of a talent show. Each of the triangles are the same size. The 3 medians are 4.2, 7.2, and 8.1 inches long, respectively. What is the distance from each vertex to the centroid of each of these triangles? So basically all it's asking is, if this was my triangle, if this was my triangle, and I'm talking centroid, okay, so that means that's where the vertexes connect to the midpoints. It's saying that the distance from the vertex to the centroid, that's the long side. The vertex to the centroid is the longer length. So it's always going to be 2/3 of the total distance. So it says use the centroid theorem. So what is the distance from each vertex to the centroid? 2/3 of the total distance. And it said that the medians were 4.2, 7.2, and 8.1. So really all this is asking us to do is multiply each of those numbers by 2/3. And we can do that really quickly in the calculator, right? Alright, that's all we need to do then.